Can humanity truly control one of the world's greatest rivers?
This structure represents the absolute peak of modern engineering ambition. Built to harness the energy of the Yangtze, it changed the Earth itself. The project created a reservoir that spans hundreds of kilometers inland. Beneath the surface, 34 turbines convert the river's raw power into electricity. Navigation was transformed, allowing massive vessels into the heart of the nation. But controlling nature carries a price that scientists monitor even today. Let us examine the history of this monumental engineering challenge. For thousands of years, rivers have dictated the survival of civilizations. Early engineers understood the balance between agricultural necessity and devastating flood control. By the 20th century, the need for reliable energy became the modern priority. Proposals for a dam at these gorges existed for decades before construction. In 1994, the project finally began, setting the stage for massive change. Millions of tons of concrete were poured into the foundation of the riverbed. The scale was unprecedented, requiring new technology to maintain structural integrity. In 2003, the reservoir began to fill, changing the landscape forever. By 2006, the primary structure stood complete, a triumph of engineering. The final turbine became operational in 2012, fulfilling the project's energy potential. Today, it stands as a testament to what human coordination can achieve. This journey from vision to reality took nearly 2 decades of effort. We look now at the technical marvels contained within these concrete walls. Digital precision guides every liter of water released through these gates. The engineering design allows for precise flood management in all seasons. Let's explore the numbers that define this modern engineering wonder. Standing 181 meters tall, it dwarfs common city high-rises.
The wall stretches for 2.3 kilometers across the Yangtze River Valley.
Behind it, a reservoir extends over 600 kilometers, storing immense energy. It features an installed capacity of 22,500 megawatts. 34 massive turbines harness this energy with incredible precision and power. Engineers conducted extensive geological studies before placing the first concrete block. Construction required moving tens of millions of cubic meters of earth and rock. Special cooling systems were necessary to prevent cracking during the concrete setting process. Computer modeling ensured the spillways could manage extreme flooding events. The navigation system was designed to allow ships to pass the dam safely. The lock system acts like an elevator for vessels of massive weight. In high-flow seasons, this structure manages water levels to prevent downstream disasters. Scientists continuously study the water quality and sediment levels behind the wall. Managing silt is one of the most difficult engineering challenges faced here.
Each turbine generates power with immense efficiency, fueling a rapidly developing economy. This energy feeds the grid of a nation, impacting millions of lives daily.
Maintenance teams operate around the clock to ensure maximum reliability of this system. The design balances structural necessity with long-term durability and safety requirements. What was once a sketch on paper has become a physical landmark of humanity.
Every feature here serves a specific purpose in this massive balancing act.
The force is breathtaking, a demonstration of human mastery over the environment. But every great achievement has its consequences for the natural world.
The reservoir has completely redefined the local ecosystem and geography. Scientists are constantly studying how the altered flow affects aquatic species.
Sedimentation changes downstream fertility, a topic of significant scientific discussion. Communities were relocated, forcing a cultural and social adaptation for thousands. Cultural heritage sites were relocated to save them from being submerged.
The region has evolved, merging industrial needs with new human realities.
Monitoring the geological impact is a continuous, high-tension task for engineers. The weight of the reservoir adds pressure to the surrounding landscape. Nature and humanity exist here in a state of complex equilibrium.
Everything is tracked, every change recorded, to understand the long-term impact.
Engineering on this scale is never just about construction.
It is about consequences.
The energy produced provides a cleaner alternative to traditional coal-fired power.
Downstream flood protection remains the most significant benefit for regional safety.
Economic growth is facilitated by this improved transit route, moving goods efficiently.
Yet, the scientific debates surrounding the dam's environmental footprint continue.
Understanding the cost involves looking at what we left behind and what we gained. This monumental work is a mirror to our own changing priorities.
The future of hydropower now faces competition from newer renewable technologies. We must rethink how giant structures can adapt to climate change challenges. Are massive dams still the best solution for our energy hunger? The answer remains a subject of ongoing scientific and engineering debate.
Great engineering projects are the legacy we leave for the generations ahead.
When humans reshape nature on a planetary scale, we change our relationship with Earth itself.
Engineering remains the ultimate expression of our ambition and our limitations.
Join us for the next episode as we explore another engineering mystery.
The greatest structures ever built hide secrets waiting to be uncovered.
From the Yangtze to the world, engineering defines who we are. This is Engineering Mysteries.